Shri Gurubhyo Namaha children. Today we are going to see test of divisibility in the multiples and the factors. See, listen children, test of divisibility. So we are going to see divisibility rules. First we'll see divisible by 2. The digit at the ones place is 0, 2, 4, 6 or 8. It is divisible by 2. So listen children, in the ones place, if it is 0, 2, 4, 6 or 8, then we can say it is divisible by 2. See, look at the example. Here they have given 150, 352, 372, 254, then 1020, then 2048. Look at the ones place, 0, then 2, 4, 6, 8. So in the ones place, if it is 0, 2, 4, 6, 8, then we can say those numbers are divisible by 2. So no need to divide this 150 by 2. So how will you say it is divisible by 2? If it is, the remainder is 0, then we can say it is divisible by 2. So no need to divide and then check. By seeing the ones place, you can tell whether it is divisible by 2 or not. By looking the numbers, then you can check the ones place. So if it is ones place 0, 2, 4, 6 or 8, then you can say it is divisible by 2. So if you want, you can divide and then check the answer. So 2 sevens are 14. So 15 minus 14, 1. Then if you carry 0, 10. So 2 fives are 10. So 10 minus 10, 0. So if the remainder is 0, then we can say it is divisible by 2. So listen children, I'll give one more example. 375. See, what is there in ones place? 5. What is there in ones place? 5. See, if it is 0, 2, 4, 6, 8, then we can say it is divisible by 2. But here in ones place 5 is there. So it is not divisible by 2. Understood children? It is not divisible by 2 because in ones place 5 is there. In ones place if it is 0, 2, 4, 6, 8, then we can say it is divisible by 2. But here 5 is there. Next rule, divisible by 5. Divisible by 5. The digit at the ones place is either 0 or 5. Either 0 or 5. So we can say in ones place either 0 or 5. Then we can say it is divisible by 5. Look at the ones place. Here 0, 5, 5. Then we can say those numbers are divisible by 5. Why? Because in ones place 0 is there, here 5, here 5. If it is in ones place either 0 or 5, then we can say it is divisible by 5. Next one, divisible by 10. The digit at the ones place is 0. If it is ones place is 0, so this is ones, tens, hundred. So what is there in ones place? 0. Here 0. Next here 0. Then these numbers are divisible by 10. Why? Because in ones place 0 is there. If it is ones place 0, then it is then we can say it is divisible by 10. So listen, 205. Always 206. So what is there in ones place? 6. So it is not divisible by 10 because in ones place 6 is there. So it is not divisible by 10. Next one, divisible by 3. Divisible by 3. The sum of the all the digits is divisible by 3. Sum of the digits. What is sum? Sum means addition, add. So sum means add. The sum of all the digits is divisible by 3. Then we can say it is divisible by 3. So they have given one example 144. So if you add 144, 1 plus 4 plus 4. So 1 plus 4, 5. 5 plus 4, 9. Whether 9 is divisible by 3? Yes, 9 is divisible by 3. 3 3s are 9. So 9 minus 9, 0. So 9 is divisible by 3. So therefore 144 is divisible by 3. Next 1236. So if you add 1 plus 2 plus 3 plus 6, 1 plus 2 3, then 3 plus 3 6, then 6 plus 6 12. 12 is divisible by 3. Yes or no? Yes, 12 is divisible by 3. So we can say 1236 also divisible by 3. Next one, divisible by 4. Listen children, the last two digits are zeros are divisible by 4. So first you should check the last two digits. So last two digits are, if it is 0 or divisible by 4, then we can say it is divisible by 4. So if last two digits are 0, so 200 is divisible by 4. Here you check last two digit 56. Then we can check whether 56 is divisible by 4. So 4 ones are 4. Then 5 minus 4, 1. Next, if you carry 6, then 4 fours are 16. So 16 minus 16, 0. So listen children, so remainder is 0. So 656 also divisible by 4. Next, what is 24? So 24 also divisible by 4 because 4 6 are 24. So 1024 is also divisible by 4. Next, 5068, we should check 68. So 68 if you are checking in 4 table, 4 ones are 4. So 6 minus 4, 2. Then if you carry 8, 4 sevens are 28. So 28 minus 28, 0. So remainder is 0. So 5068 also divisible by 4 because 68 is divisible by 4. So therefore 5068 is divisible by 4. Next, divisible by 6. The number is divisible by both 2 and 3. Both 2 and 3. So the number should be divisible by both 2 and 3 means then we can say it is divisible by 6. See, look at the example 432 they have given. So how will you check whether it is divisible by 2 or 2 and 3? For 2 you have to check the in ones place. In ones place its 2 is there, so it is divisible by 2. Next, for 3 what you have to do? You have to add. So sum of the digit. So 4 plus 3 plus 2, 4 plus 3, 7. Next 7 plus 2, 9. So 9 is divisible by 3. Then we can say 432 is divisible by 3. Next one, divisible by 9. See, listen children, same as 3, same as well as 3. Divisible by 9 also. The sum of the digit is divisible by 9. Sum means addition. I told you already. Sum means add. So they have given 729. If you add 7 plus 2 plus 9, 18. So 18 is divisible by 9. 18 is divisible by 9. Then we can say 729 is divisible by 9. So sum of the digits. So if you add the numbers, 8100 they have given. So if you add 8 plus 1 plus 0 plus 0, 8 plus 1, 9, 9 plus 0, 9, 9 plus 0, 9. So 9 is divisible by 9. Then we can say 8100 is also divisible by 9. So these are the test of divisibility. Thank you children. To receive our online lessons, please press the subscribe button and you will get the latest updates.